Okay, so today I would like to talk about a very common formula that we use in both geometry and algebra. It's actually used in the construction field. It's used actually many places, anywhere there is a right triangle. It is called the Pythagorean Theorem. Many of you guys have heard of this before. The Pythagorean Theorem is a squared plus b squared equals c squared. And you'll notice here that I've got drawn a triangle. It only works for a what we call a right triangle, a triangle that actually has a 90-degree angle. Now, if you look at my triangle here, you will notice that there's this little box that's been drawn in the corner, and that's the notation that we use in geometry to designate a right angle or a 90-degree angle. So that angle there is 90 degrees. You don't have to really worry about that all that much when it comes to in algebra, but in geometry we'll be finding missing angles in this sort. So the first thing I want to talk about before I actually do an example is you will notice the order of things here. It is very important that A and B are what we call the legs. You'll notice here that the A is on this side and the B is on that side. Those are what we call the legs of the hypotenuse. The legs are the sides that are adjacent to the right angle. In other words, the right angle is in the middle of the two legs. Those are both considered the legs. The C, on the other hand, is what we consider the hypotenuse. And you will notice that the hypotenuse is exactly opposite of the 90 degrees. Now, it is true that you can label A and B, you can switch those two because addition is commutative, but C must be placed in the correct side. I tell my students I use a rule where I just simply tell them that A is going to be the smallest side, and therefore I say A can be less than or equal to B, and B actually has to be less than C is what it is. So this is kind of the rule of thumb that I use, and I tell my students I just go from small, A is the small side, B is the medium side, and C is the longest side. If you stick with that rule, it will keep you out of a lot of trouble. Okay, so for my first example here, you'll notice that I have a missing side here. I've given one leg that has a length of 3, one leg that's given a length of 4, and the other leg is missing. And many times we like to use just simply the letter X for a missing side. Well, what I would like to do first is actually what I would like to determine is what is my A, what is my B, and what is my C. And so underneath this triangle, I'm going to go ahead and label these values. I notice here that A is the shortest side. I'm going to go ahead and label A is equal to 3. B is my medium length. I'm going to go ahead and list B is equal to 4. And C is my longest length. But I don't know C. C is equal to question mark. And we can actually let just C equal the variable X, or you can leave it as such. My first step is I'm going to go ahead and take the equation here that I have, A squared plus B squared equals C squared, and I'm going to go ahead and plug in the values. Now, before I actually plug in those values, what I like to do is I like to give myself what I consider an empty shell. And so you'll notice here what I've done is I've taken each position where there was an A, I replaced it with a set of parentheses. Where there was a B, I also replaced it with a set of parentheses. And where there was a C, I replaced it with a set of parentheses. Now I can actually plug in my A. My A is the value of 3. My B is a value of 4. And my C I don't know. And so you can either label it as X if you'd like, or you can label it as C. It doesn't matter. I'm going to go ahead and replace it with X. Here, when I multiply this out, 3 squared, remember I have to do order of operations, so I must square this before I can add. 3 squared is going to give me 9. I'm going to copy down the plus sign. 4 squared is going to give me 16. And this on this side is simply going to be x squared. I'm going to give myself a little line here to separate those two. On the right hand side, I just simply have an x squared. I don't have to do any work with that. But on the left hand side, I actually have 9 plus 16, which can be combined to be 25. The last step that I need to do is I need to actually get rid of the square. So I've actually been asked to find the side. I need to solve for x. I don't need x squared, and so I'm going to use the inverse operation, which I'm actually going to take the square root. So I'm going to square root the left, and I'm also going to square root the right. When I do that, the square root of x squared simply becomes x, and the square root of 25 is 5. That is the length of my missing side. Okay, so for the second example, you will notice once again I have a missing side. I've been giving a right triangle in which the shortest side is a 5. The medium length side, or the other leg, has just been labeled y. I'm missing that. And the hypotenuse, the longest side, is 12. So the first thing I'm going to do, once again, is I'm going to go ahead and label my values. So at first I have a is equal to 5. That's good here. And I can go ahead and plug that 5 right into my equation under a squared. Okay, so you'll also notice now that I've got my a, my b is actually y here, and so I'm going to go ahead and write b is equal to y. That's the missing value. That's my missing side, the side that I'm going to try and find. And then lastly, my c is actually equal to 12, and I'm going to go ahead and plug that value in. Now I'm going to go ahead and calculate each one of these off, coming back over to my a squared plus b squared equals c squared. 5 squared gives me 25. I'm going to go ahead and copy down the plus sign. Y squared is just simply y squared. I don't know what that is yet, so I'm going to go ahead and just copy that down. And 12 squared, of course, is 144. Now the first thing that I notice is that when I'm solving this equation, my y isn't actually by itself. There's a 25 that's in front of it. I would like to get rid of that 25 in this scenario, and so I'm going to subtract 25 on the left-hand side, and whatever I do to the left, I also must do to the right. I'm going to go ahead and subtract 25 on that side as well. When I do that, the 25's cancel, and what am I left over with is y squared is all equal to 144 minus 25. 144 minus 25 is going to be 119. Check my math on that real quick, but I'm pretty sure. And then when I go ahead and take the square root of this, I'm going to square root the left, and I'm going to square root the right. Now on the left hand side, the square root of y squared simply gives me y. But on the right hand side, I have what's called an irrational number. I have the square root of 119. And this is actually not as rare as you would think with the Pythagorean theorem. I've ended up with a number that is not a perfect square, and therefore my answer is simply y is equal to the square root of 119. I hope this video has helped you with the Pythagorean theorem, and I hope you have a great day.